is entanglement.
Entanglement is a theoretical prediction that comes from the equations of quantum mechanics. Two particles can become entangled if they're close together and their properties become linked. Remarkably, quantum mechanics says that even if you separated those particles, sending them in opposite directions, they could remain entangled, inextricably connected. To understand how profoundly weird this is, consider a property of electrons called spin. Unlike a spinning top, an electron spin, as with other quantum qualities, is generally completely fuzzy and uncertain until the moment you measure it. And when you do, you'll find it's either spinning clockwise or counterclockwise. It's kind of like this wheel. When it stops turning, it will randomly land on either red or blue. Now imagine a second wheel. If these two wheels behave like two entangled electrons, then every time one landed red, the other is guaranteed to land on blue. And vice versa. Now, since the wheels are not connected, that's suspicious enough. But the quantum mechanics embraced by Niels Bohr and his colleagues went even further, predicting that if one of the pair were far away, even on the moon, with no wires or transmitters connecting them, still, if you look at one and find red, the other is sure to be blue. In other words, if you measured a particle here, not only would you affect it, but your measurement would also affect its entangled partner, no matter how distant. For Einstein, that kind of weird long-range connection between spinning wheels or particles was so ludicrous, he called it spooky. Spooky action at a distance.
What's surprising is that when you make a measurement of one particle, you affect the state of the other particle. You change its state.
There's no forces or pulleys or, telephone wires. There's nothing connecting those things, right? How could my choice to act here have anything to do with what happens over there?
So there's no way they can communicate with each other. So it is completely bizarre. And it was something that Einstein realized in 1935.
Einstein just could not accept that entanglement worked this way, convincing himself that only the math was weird, not reality. He agreed that entangled particles could exist, but he thought that there was a simpler explanation for why they were linked that did not involve a mysterious long-distance connection. Instead, he insisted that entangled particles were more like a pair of gloves. Imagine someone separates the two gloves, putting each in a case. Then that person delivers one of those cases to me and sends the other case to Antarctica. Thanks. Before I look inside my case, I know that it has either a left hand or a right hand glove. And when I open my case, if I find a left-hand glove, then at that instant, I know the case in Antarctica must contain a right-hand glove, even though no one has looked inside. There's nothing mysterious about this. Obviously, by looking inside the case, I've not affected either glove. This case has always had a left-hand glove, and the one in Antarctica has always had a right-hand glove. That was set from the moment the gloves were separated and packed away. Now, Einstein thought that exactly the same idea applies to entangled particles. Whatever configuration the electrons are in must have been fully determined from the moment that they flew apart. But it's the act of measurement that brought that spin to a definite state. No one knew how to resolve the problem. The whole question came to be considered philosophy, not science. In 1955, Einstein died, still convinced that quantum mechanics offered, at best, an incomplete picture of reality. 1967, at Columbia University, Einstein's mission to challenge quantum mechanics was taken up by an unlikely recruit. John Clauser was on the verge of earning a PhD in astrophysics. The only thing standing in his way was his grade in quantum mechanics.
When I was still a graduate student, try as I might, I could not understand quantum mechanics.
Clauser was wondering if Einstein might be right when he made a life-altering discovery. It was an obscure paper by a little-known Irish physicist named John Bell. Amazingly, Bell seemed to have found a way to break the deadlock between Einstein and Bohr and show once and for all who was right about the universe.
I was convinced that the quantum mechanical view was probably wrong.
Reading the paper, Clauser saw that Bell had discovered how to tell if entangled particles were really communicating through spooky action, like matching spinning wheels, or if there was nothing spooky at all, and the particles were already set in their ways, like a pair of gloves. What's more, with some clever mathematics, Bell showed that if spooky action were not at work, then quantum mechanics wasn't merely incomplete, as Einstein thought. It was wrong.
I came to the conclusion that, my God, this is one of the most profound results I've ever seen.
Bell was a theorist, but his paper showed that the question could be decided if you could build a machine that created and compared many pairs of entangled particles.
Bell turned the question into an experimental question.
It wasn't just going to be about philosophy or trading pieces of paper.
And the experiment that he envisioned could be done.
You could really set up an actual experiment to force the issue.
Clauser set about constructing a machine that would finally settle the debate.
Now, I was just this punk graduate student at the time. This really seemed like, wow. There's always the slim chance that you will find a result that will shake the world.
Clauser's machine could measure thousands of pairs of entangled particles and compare them in many different directions. As the results started coming in, Clauser was surprised and not happy.
I kept asking myself, what have I done wrong? What mistakes have I made in this?
Clauser repeated his experiments, and soon French physicist Alain Aspect developed some even more sophisticated tests, with one going to the heart of the Einstein-Bohr debate. In Aspect's test, the only way that measuring one of the particles could directly influence the other would be for a signal to travel between them faster than the speed of light, something Einstein himself had shown impossible. The only remaining explanation was spooky action, and so Aspect's experiment removed virtually all doubt. The results of these experiments are truly shocking. They prove that the math of quantum mechanics is right. Entanglement is real. Quantum particles can be linked across space. Measuring one thing can in fact instantly affect its distant partner, as if the space between them didn't even exist. The one thing that Einstein thought was impossible, spooky action at a distance, actually happens.
I was, again, very saddened that I had not overthrown quantum mechanics, because I still had, and to this day, still have great difficulty in understanding it.
That is the most bizarre thing of quantum mechanics. It is impossible to even comprehend. Don't even ask me why. Don't ask me which we're going to, how it works, because it's an illegal question. All we can say is that is apparently the way the world ticks.
So if we accept that the world really does tick in this bizarre way, Could we ever harness the long-distance spooky action of entanglement to do something useful? Well, one dream has been to somehow transport people and things from one place to another without crossing the space in between. In other words, teleportation.
Beam me aboard. Energize. Energizing.
Star Trek has always made beaming or teleporting look pretty convenient. It seems like pure science fiction, but could entanglement make it possible?
Because it's an illegal question. All we can say is that is apparently the way the world ticks.
So if we accept that the world really does tick in this bizarre way, could we ever harness the long-distance spooky action of entanglement to do something useful? Well, one dream has been to somehow transport people and things from one place to another without crossing the space in between. In other words, teleportation.
Beam me aboard. Energize. Energizing.
Star Trek has always made beaming or teleporting look pretty convenient. It seems like pure science fiction, but could entanglement make it possible? Remarkably, tests are already underway here on the Canary Islands off the coast of Africa.
We do the experiments here on the Canary Islands because you have 2 observatories, and after all, it's a nice environment.
Anton Zeilinger is a long way from teleporting himself or any other human. But he is trying to use quantum entanglement to teleport tiny individual particles. In this case, photons, particles of light. It goes something like this. He starts by generating a pair of entangled photons in a lab on the island of La Palma. One entangled photon stays on La Palma, while the other is sent by laser-guided telescope to the island of Tenerife, 144 kilometers away. Next, Zeilinger will bring in a third photon, the one he wants to teleport, and have it interact with the entangled photon on La Palma. The team will study the interaction, comparing the quantum states of the 2 particles. And here's the amazing part. Because of spooky action, the team will be able to use that comparison to transform the entangled photon on the distant island into an identical copy of that third photon. It will be as if the third photon teleported across the sea without traversing the space between the islands.
Sort of extract the information carried by the original and make a new original there.
Using this technique in other locations, Zeilinger has successfully teleported thousands of particles. But could this go even further? Since we're made of particles, could this process make human teleportation possible one day?
Welcome to New York City.
Let's say I want to get to Paris for a quick lunch. Well, in theory, entanglement might someday make that possible. Here's what I'd need. A chamber of particles here in New York that's entangled with another chamber of particles in Paris.
Right this way, Mr. Green.
I would step into a pod that acts sort of like a scanner or a fax machine. While the device scans the huge number of particles in my body, more particles than there are stars in the observable universe, it's jointly scanning the particles in the other chamber, and it creates a list that compares the quantum state of the 2 sets of particles. And here's where entanglement comes in. Because of spooky action at a distance, that list also reveals how the original state of my particles is related to the state of the particles in Paris. Next, the operator sends that list to Paris. There, they use the data to reconstruct the exact quantum state of every single one of my particles. And a new me materializes. It's not that the particles traveled from New York to Paris. It's that entanglement allows my quantum state to be extracted in New York and reconstituted in Paris, down to the last particle.
Bonjour, Monsieur Green.
Hi there. So, here I am in Paris, an exact replica of myself. And I better be, because measuring the quantum state of all my particles in New York has destroyed the original me.
It is absolutely required in the quantum teleportation protocol that the thing that is teleported is destroyed in the process. And, you know, that does make you a little anxious. I guess you would just end up being a lump of neutrons, protons, and electrons. You wouldn't look too good.
Now, we are a long way from human teleportation today, but the possibility raises a question. Is the Brian Greene who arrives in Paris really me? Well, there should be no difference between the old me in New York and the new me here in Paris. And the reason is that, according to quantum mechanics, it's not the physical particles that make me me. It's the information those particles contain. And that information has been teleported exactly for all the trillions of particles that make up my body.
It is a very deep philosophical question whether what arrives at the receiving station is the original or not. My position is that by original we mean something which has all the properties of the original.
New York City.
And if this is the case, then it is the original.
I wouldn't step into that machine.